So this is starting with Murph last year, and E3D released the tool changer there, or described the tool changer there. So that sort of got me thinking about tool changing. And I'd already set up another printer with similar characteristics to this for Earth. And I picked this up, and I was thinking, like, what the idea of tool changing sort of on the mind. I was thinking of ways to do that. And I didn't really, I had the frame here, and I'll describe sort of the motion system for this in a minute. But I was thinking about how to do this. And, you know, the E3D way with actually changing heads was pretty neat. What I got to thinking about was, like, is there a way I can mount multiple hot ends on this so that they can all be used at one time? And I didn't know exactly how I was going to do it. I just had this frame here. And I actually walked into my laboratory and had old microscopes in there. And the objective lenses on a microscope, the way they work essentially is you turn a carousel, and then every objective lens is pointing in the same direction. And for me, that was the inspiration for building this. So it's a carousel-based tool changer, where essentially you just rotate the hot ends around to get a single hot end in the position that you want every single time. So probably turn it on to get a little bit of motion here. So the original frame for this is a Beckman biomech liquid handling robot. And one of the things that all of these, I try to use as much original equipment as possible. So rather than having stepper motors for the X-Y axes, this uses a closed loop system, so they're DC servo motors. In order to run that is a bit of a complication. So one of the things you have to do is you have to have something that are interpreting step and direction inputs from, this is just using a ramp 1.4 board to control most of the stuff on here. So there's an entirely separate motor controller that have Arduino Pro micros that are interpreting step and direction from the ramps board. They're reading the encoders on these motors. So being a closed loop system, essentially you never lose any steps. So you can grab an axis and push it, move it around, and go exactly back to where it's supposed to be. So that's one of the things that I think will be coming more into the 3D printing realm. These dumb stepper motors that we use are, well, they're just that dumb. So having smarter setups like this would be the way to go. And I think once we're using 32-bit boards, getting away from ADR, that'll be a sort of common builds thing. Along with this, though, because I'm using ramps, there was a bit of a difficulty with how I was going to do hot end control. So there are 5 hot ends on here. And being able to run all those hot ends from the ramps board itself was a bit difficult. So I offloaded everything onto a hot end control board. So this basically just takes PWM signals from the ramps board. All the MOSFETs and everything are on there. The thermistors are red, and there's a third Arduino Pro micro on there. They're actually reading the thermistors and sending back to the ramps board via serial. So you don't have to have all of the analog inputs on the ramps board reading independent thermistors. So it was really a matter of splitting this thing up into multiple pieces. And then for all the extruders that I needed on this, really the only way that I saw to do this was to use a switch, because you didn't need them running at the same time. So I had an old Prusa MMU 1.0 that I never installed because the one that I did install was buggy enough. So I had an extra stepper switch, so that's controlling 4 of the motors, and then 1 is controlled independently by the ramps board. This freeing up the X-Y axis actually also freed up the Z axis. So I actually have 3 independent stepper motors driving the Z axis, so you can actually do bed leveling correction independently on that, which is kind of a nice thing. Maybe I'll plug some things in. We can show a little bit of it working, at least in the tool chamber.
Do you have a Z-bed probing?
There is. There's a DL Touch that's included on here,
which does all the Z-bed probing. Maybe while I'm firing this up, if you have any other questions.
Build by?
it is about right around 600 by 320 by 440 or something like that. I haven't gone very far in Z yet, but I have. the nameplate on here. So maybe this is fitting because we have the White Knight here and we have the dragon. So because of its name is actually Tiamat, which is from those who play Dungeons and
Three-headed dragon.
It's a 5-headed dragon, actually. So there were 5 hot ends, so I thought a 5-headed dragon would make sense. So that's the name on this. So for example, if you want the tool changing here. So we can switch the tools. So it just goes back and forth. I'm just switching here. It was definitely a bit complicated figuring out how to do the tool changing. So all I'm really using is a hobby servo to do this, but keeping the position. Using a hobby servo was a bit difficult. So the way that I have this designed is there's essentially a sled underneath the carousel, and then there's essentially these springs and ball bearings. They're used dentons to hold it in place. And so as long as you get the hobby servo close to where it needs to be, there's enough of these in the positions that hold them in place. And I would say that the tool change accuracy, it's definitely not like whatever E3D has, like 14 microns on theirs. It's not even close to that. But for sort of a home-built machine, it's working better than I expected. Though I will say that I went through about 6 different iterations for how I was going to try and do this. And this is what I've settled on now. Ultimately, I'm not going to get it done for MRF, but ultimately I have another DC servo motor with an encoder which will essentially work on there. So I think that'll help the positional accuracy a lot, just by being able to read the encoder on the hot end controller and just turn to the position you want, and that should work out.
I like that you have a project already lined up for Earth.
Yeah, exactly. That will be the Earth upgrade.
What's the angular difference between the heads?
23 degrees. So those that read the Illuminatus trilogy when they were kids, 23 is an important number.
If you wanted to make more of these, how readily available?
Extremely unavailable. So as I said, this frame itself and the motion control system, originally when purchased, I have.
Gusner, it's Arduino controlling the servo.
I think it was like
it's Arduino Micro, I think you said.
For this thing. I mean, there was a lot of other stuff that was involved with it, racks and tubes and pumps and all kinds of other stuff that was part of
Windows
this.
3.1 computer or something.
Oh yeah, exactly. Yeah, Windows. It was probably Windows 98 when this thing came out. But there are a lot of issues with this. One of the things that you get when you have these rather thick planetary gears on these DC servo motors is that there's a lot of backlash within here. So those are things to play with. Fortunately, our tools are getting a lot better. So Marlin 2.0 has backlash correction. It has all the things that I need to do the bed leveling. Actually, maybe that's one thing we do here, but I can just show you the. Yeah, so here's what we're just homing here. It's not a fast printer. If you actually look at the top of this whole carousel is huge. So you're not going to be able to push that around very quickly. That's one of the limitations I went into it knowing that was going to be the case. So print slowly.
Using Octoprint there or something?
I am, yeah. So now we're doing this is the independent Z-axis motor control. So it'll go through and it'll probe 3 points near each of the lead screws that are on this, and then you'll actually see that there'll be adjust the position of all 3 of them.
Does it then go back and reprobe?
It does it 3 times. Yeah, you can set how many times you want to do it. So right there was the leveling.
Paul, while it's doing that, can you go over what boards it was running? What all controls you're using on it?
So the main control board is just a Ramps 1.4 board. There is a independent motor controller, which is 2 Arduino Pro Micros,
And then there's a dual channel H-bridge motor controller. It's I don't remember what model it is. And then the hot end controller, everything's on another Arduino Pro Micro. That'd be the quietest X and Y movement I've ever. Yeah.
Yeah, that thing's super quiet. Just a little.
It's nearly silent.
Are you running just a Gcode script to do the?
Yeah, this is just all in Gcode. So I would say that the thing that took me the most time with this, actually, well, aside from the tool changer itself, was doing all the Marlin adjustments to be able to work this, because it's pretty well documented, but I don't really know any C++, so figuring all that stuff out. For example, how to activate the second serial port on the AT Mega and actually use that, and I had to basically totally hack up the temperature readings the way it's done in Marlin, so that it's not reading off of the ABCs. It's actually reading from the serial port, so that took some doing.
So that exterior control board, is that off the shelf component, or is that your own?
That's my own. So there are two PCBs, the sort of the motor controller and the hot end controller, which are PCBs that I designed. So I'm sure there are things that are very wrong with them, but and I think this is a good contrast with Carl's very nice clean work and so,
Chris is getting a close up.
I did make it so that I can take all of this stuff off the back, because the only way that I could get it in and out of my basement was actually flipping it on the back. So I can just take all these pieces off and turn it on the back and slide it up the stairs. There are a number of other things that I was happy to be able to do. Like, I mean, I didn't necessarily want to have 5 fans on each hot end. I was thinking of a solution where I could just have a single fan that was working for all of those. I ended up having 5 fans, but at the same time, when I decided that was the way that I had to go, I have independent fan controls, cooling fans for all the hot ends, so only the ones that need to turn on. So it is, there's some noise reduction there as well. But yeah, that's about it.
Do you have any print samples?
I do. I have some. So, this is like the standard thing that you do if you're printing multi-material. So, and I think these are some iterations. So, the hardest thing, as you would imagine with a tool changer that works this way, is getting the offsets right. So that's been a challenge. And anytime you take hot end off, so I've made it sort of modular. You can pull individual hot ends off if you need to work on them. But anytime you do that, offsets change, and then you've got to fix all the offsets. So that's a certain downside to the way this is. This was my first attempt at 5 colors, so a 5-color bin sheet. The snake is.
Wow.
I haven't done any actual multi-material, so I've just stuck with PLA on this. Obviously, no heated bed. PLA sticks like gangbusters to this acrylic bed. So.
Question in the chat: do you set each Z offset individually for the tool?
Yeah. So interestingly, the Z offsets stay very, very close. I don't have a whole lot of issue with Z offset. XY offsets are more of a challenge.
Do you think that's mainly because of that 23-degree angle that you get subtle variances on the other kind of correct floor?
Yeah, I'm not sure. Well, yeah, I think it's actually just the positional accuracy of the head as it swings around. If you don't get it lined up, so it's going to be off a little bit. The one thing that I have tried to do is wherever I can, I'm closing the loop. So I actually do have it set up so that I can detect whether or not I have a correct tool change. So the way this is done is on the Pro Micro that's on there, and this is the carousel. Actually, you see these little wires that are sticking out here. So this is essentially going to the ground, and then I just run an input pull-up on the Pro Micro. So, and I have it in my pocket, I think. this is the sled that it sits on, so you can see that this is the way it goes. And so this is running to the input pull-up. So when it's centered, it'll actually close the loop, and you can know that it's centered. And so if you get a bad tool change, it's not activated right now, but if you get a bad tool change, you can pull everything back and then go to another tool position and come back so that you can try to get it to the correct position. So, yeah.
I'm curious, I know you spoke about your background, what exactly do you teach?
I teach biochemistry.
Biochemistry?
Yeah.
That would explain the machine. What was your, and you probably explained it to some point, but what was your desire to actually repurpose something like this?
The desire, I don't know. I think that's just like the tinker desire. Like you see something, you know, I see an XY motion system, and once I got into 3D printing, as soon as I see that on everything, it's like, I wonder how I could make that into a 3D printer or a laser cutter. I mean, it's just that just happens right away.
Next up is a treadmill.
The similar type of machine, my wife works in hospital lab supervisor there in town. Similar type of machine right now is $1.4 million.
Yeah. Yeah. Well, they're a lot more complicated these days than. Yeah, that's right. Yeah. And so this wasn't back then. And the other one that I had at Earth last year was actually from Swiss company, whose name I can't now no longer remember. And that was a little different setup. So that had XYZ already integrated, which was kind of a neat way. This, I had to actually build the Z-axis on this, so that's one of the things that I probably could have spent a little more time on and done a better job. So it's just open builds, extrusions that I kind of figured out how I was going to put them in there to make the Z-axis.
About the colors. How does neon colors work?
How do the colors work? So each color goes to one of the atoms. So
The model, the actual job.
how to actually generate the model. So you have to have multi-material models to begin with. That's actually one of less of a limitation now, but that was one of the things that I've noticed before when trying to do multi-material prints. There aren't a lot of things out there. One of my motivations for wanting to even start multi-material printing and getting the Crucian and 1.0 was I do most of the 3D printing for educational purposes. So because I teach biochemistry, I actually 3D print molecules. I work on DNA, so I do lots of printing of DNA, and actually being able to print different atoms in different colors and be able to give those to students was one of the things that I wanted to be able to do.
Some materials in the model, you don't know what you just color.
Yeah, so for example, Palette has something now where you can actually go on and you can color what parts of the model you want to be different colors.
Not yet.
It's not available yet.
Not-
The paint feature or whatever?
Yeah, it's
They're working
coming.
with the painting feature for the model, so you would actually have the model up and say, yeah, put this color here. But right now, it's still four separate
STL
files, and you
files.
say this file gets that color.
Yeah. So basically you have to have things that are split into, and if you get some people who are good with mesh mix or something, they can split it up for you. I will say that, I mean, sort of to your question, I mean, I would happily open source this and tell everybody everything that I've done on this. If somebody had another one of these that they wanted, or a similar project, I'll share everything that I have. I did all of the things that I need to design done in Blender. So.
Do your work where?
Yeah, it's also one of those things where I started working with Blender, so once I got into it, you kind of know it.
What do you think of the new Blender? Have they simplified it a lot?
They have. They've changed the default mouse buttons, which I think will help a lot of people. Well, yeah, it's a little bit of a pain, but it's also very customizable. So if you're willing to spend some time customizing Blender for yourself, you can and get it to work however you want.
It's not as intuitive as my job.
No, probably not. But I'm a Linux guy, so I don't even have a Windows install anywhere, so I can't use Fusion 360. So. Somebody tag them on one of these things. Anything else? No?
What was your cost?
I could give you an estimate, but it's probably gonna be totally wrong. I'd probably spend about $1,000. And I can tell you that the one largest cost that I had was that I was a bit naive going into this. So this is actually, these are 36 volt, well, this is a 36 volt motor. And it had a 36 volt power supply. I'm like, ooh, I'm gonna have, this thing's gonna be beefy. I'm gonna be able to swing these axes around pretty fast. What I didn't really recognize is that the AVR, their ability to handle interrupts, they can't handle things that are shooting at 36 volts. And so when I first fired it up, it was actually, this motor was on the Y-axis, and the X-axis motor I had going, and it just basically shot across and banged into the side. And yeah, I burned up one of these motors, and this is, I don't know, it's a Maxon A-Max. This is probably a $200 decent servo motor. So I bought a replacement. I found a replacement on eBay, which is not quite as good. So I got sort of mixed motors here. But yeah, that was a bit costly.
Paul, just real quick, I'm going to end the live stream. Where can everybody follow you if they want to see more of this? Because you're posting pictures all the time and stuff.
Yeah, basically I'm just posting stuff about this on Twitter. So Paukstelis on that Twitter. I don't really do much of other stuff.